Okay, welcome to part two. Now, again, I asked you to think about what a reflected cosine graph would look like. So, looking up here, look at the original graph. So, cos x right here, let me just get that stuff out of the way. Cos x, the red one here, starts at its maximum, okay, and then goes down from there. Now, this one has been reflected. So, instead of starting at its maximum, reflect this point across. Now it's going to start at its minimum and then go up from there. So our graph down here, we're going to do the exact same. It's going to start at the minimum value instead of the maximum value, and then go up. So we'll go from the minimum up to the axis, up to the maximum, back down to the axis, and then finally reach its minimum again. Once we have those key points in place, we can draw the rest of the curve here and be done our sketch. Okay, so even after you fill in all the key x values, all the key y values, you still got to think about what the graph looks like, and that's going to depend on the parent function, which in this case was cosine, and whether or not it's been reflected. If it's been reflected, it has the opposite behavior, so you reflect. So if it's a cosine graph, it's going to start at its minimum. If it's the sine graph, it'll start on the axis still, but then go down instead of up. Or if it's not reflected, in which case it'll be the same as the parent function. Okay, so with that in mind, there's just a couple more examples to try. Here's one I'd like you to try. And so again, try and fill in everything you can about the chart, and then try and fill in the rest of the graph from there. Okay, but if you want to check your chart before you do the graph, yeah, please do so. So push play and ready to see the chart. Okay, so take a second, check your answers here. A couple things to note here. You'll notice here for the period again, it's 360 degrees divided by your k value. Your k value is a fraction here. Just be a little bit careful here when you're dividing it out. So 360 divided by 2/3. Dividing by 2/3 is the same thing as multiplying by 3/2, so you get 540 degrees. One thing you have to watch out for here, and we touched on it last lesson too, is to deal with a phase shift. You can't just blindly take the value you see in the equation as being your phase shift, because it only works if the k value is factored out of what's inside the sine or cosine. So if you want to get the phase shift, and again, I recommend that you do this because it tends to lead to a lot of mistakes if you don't, make sure you factor the 2/3. So I did that over here. Take the 2/3, factor it out. When you try and figure out what's left over, you get x minus, and then you get 80 degrees. You factored out the 2/3, so it's 80 divided by 2/3, which again is the same thing as 80 times 3/2. So 80 divided by 2/3 is 120. So you get x minus 120 degrees. And it's from there that you wind up getting your phase shift, being right 120 degrees. Okay, so with all that in mind now, you have your range, your axis, your amplitude, your map rules you don't really necessarily need. We can start creating our sketch. Okay, so let me just clear a lot of this out of the way. So for our sketch, so y values first. Axis goes in the middle, put your -5, amplitude is 2. You go up 2 to get -3, down 2 to get -7. Okay, my phase shift is right 120, so I start my cycle there. I end it 540 degrees later, so 120 plus 540 is 660 degrees. Okay, and to find out the rest of my x values, I take my period, divide it by 4. So 540 degrees divided by 4 is 135. So I'm going to add 135 for each amount that I go up, each quarter of the cycle that I go up on x. So 120 plus 135 is 255. Okay, and then I get 390, 525, and then of course 660. Okay, so again, once all that's in place, I'll take a look at my graph. It's a sine graph. Sine graph starts on its axis always. Now I got to figure out what direction it's going to go. It has not been reflected, so it'll be the exact same as the parent function. So it'll go up from there, then reach its axis, go back down to the minimum, and go back to the axis. So there's my curve. Okay, so hopefully it's starting to make a bit more sense after a few examples. I want you to try the last one completely on your own, and when you're ready to see the answer, push play, and you'll be able to go through it together. Okay, so take a look and check your values here. Now, in order to get the phase shift, I have to factor out the k value of 15. So when I factor out the 15, I get x plus 6 degrees. X plus 6 degrees means we're shifting left 6. For the period, I did 360 divided by k, which was 15. 360 over 15 gives me 24 degrees. So that means for my graph here, for the y values, my axis was at 12, my amplitude was 4, so I go up 4 from the axis to get 16 as my max, down 4 to get 8 as my minimum. I'm starting left 6 degrees, so from 0 going left 6 means you start at negative 6 degrees. I added the period of 24 to give me an endpoint of 18 degrees for this cycle. When I divide the period by 4, 24 degrees divided by 4 is also 6 degrees, so I'm adding 6 degrees every time I go up a quarter cycle. Okay, that gives me the rest of the x values. Okay, and then all you need to figure out now is my shape. So it's a cosine graph that has not been reflected. So cosine graph starts at its maximum. Again, it's not reflected, so it stays there. So maximum to axis to minimum to axis to maximum. I get my cosine curve. Okay, so that's it. That's all. Hopefully it's starting to make a bit more sense now. Please make sure you do a lot of practice. There's some worksheets thrown in there too that have some good extra practice in there as well. So that's it, and then we're going to start doing some more stuff with these next lesson. Okay, that's it.